Hello, and welcome to the third video in our series describing the utilization of the Kinome Toolbox. This third video is going to describe to you Level 1.0.0 data. So in our previous video, we discussed the bit shorteners for URLs to load in data in groups more easily. This is one of the first URLs you can find in the publication. If we go to it, we'll see that we're being told we're going to get redirected, and we will be redirected. And what we'll see if we scroll over to the Data tab is that we have our sample list loaded in for our level 1.00. Each one of these samples is in a group based on the sample type. And if we wanted to see other information about these, such as the PAM chip location, we could see the location on the PAM chip itself. Once again, from here, we can navigate to any of the other collections, including back to the same one. But when a specific type of data is loaded into the system recognizes specific analyses that it can do. So when we click on these Analyses Available tabs, we can see both find outliers and generally visualized data. So what I'm going to do is click over here to find outliers. This is going to run some sort of analysis. In this case, it's going to attempt to find outliers on the nonlinear curves. I'm going to go ahead and begin this because it takes a moment to run. And in the meantime, we're going to look at the visualization of the curves themselves. So the fits are going to run. We're going to switch over here to the visualizer. So this is what we call our peptide picker. It is a virtual array composed of all of the peptides on the specific chip. Before we select any of these particular peptides, we're given some basic information about the sample. So we know this is level 1 data. We know the barcode for this sample. We know the sample name and the sample type if that information is available. The other thing we know is the sample ID, which is indicated by the barcode well combination here. And we can see that we can go through and select all of the other samples as well. If we go ahead and select one of these peptides, what we'll see is we load in a significant amount of information about the peptide itself, including the sequence and the phosphorylatable residues, in this case, tyrosine, located here and here. An additional piece of information we load in is the UniProt accession number for the source protein. If we click on this, we'll open up a new tab, and we can see the UniProt page itself. Scrolling down further, we also have access to the image data itself. So each one of these arrays is a specific image that was captured. In this case, we have a post-wash image, which is captured at the end of the reaction at 50 milliseconds. So when we click on this, we will see a 50 millisecond camera exposure time for the post-wash figure. These images tend to be low resolution here because they are naturally TIFFs, which do not display well on the web. However, we can download the original image and get the full high-quality image for our own analyses. But this gives us a general idea of what the array looks like. So if we come back to our virtual array, what we'll see is we can scroll down and take a look at a couple of pieces of information. We can look at both the cycle series, or the kinetic data, for the signal, and then for the background as well. In our first video, we discussed how these backgrounds worked. Essentially, your signal is the spot itself, and the background is a measure of the signal in the four corners around it. This gives us an idea of what signal is being created by that signal versus what signal might be created by the spots surrounding the original spot. As we can see, we can scroll down. As we can see, there are fits for both of these curves and some measure of goodness of fit, in this case, R squared, and the Wald-Wolfowitz p-value, which indicates the randomness of the residuals. And then we also have the equation for the fit itself. If we scroll down further, what we're seeing is the post-wash lines. And we can see here a spot that's been excluded. That spot has been excluded because it's past the saturation point of the camera. The maximum detectable value is 4095. So this has defaulted to 4095, so we have ignored it for our fit. And we can see that this is fit nicely with a linear equation and an R squared value here. We can scroll up here and take a look at the fact that we have post-wash at 50 millisecond exposure time. If we scroll to a different cycle number, we can see that our virtual array changes. And we can also scroll down here and see that our data has changed for our exposure versus signal and our exposure versus background for this particular image, as well as our image has changed if we were to open this. So the one last thing to point out is this peptide search box. What this can allow us to do is find specific peptides that we might be interested in. So in this case, we might be looking for all these Sark proteins. And so if we typed in SRC, and this is case sensitive, we would find the 3 SRC peptides that are available for this. So while we've been talking, our outlier detection has been running. So go ahead and switch over to our outlier detection. What we're going to see is a new virtual array. This virtual array, however, is colored by the number of outliers detected. So we're going to go ahead and click over to our SARC8 here again to look at what exactly an outlier is. So if we scroll down, so we can see that this outlier has already been removed. But if we look up here, what we can see is that this outlier is a new one to be removed. And this has been removed because the algorithm has detected that it has significantly thrown off the curve fitting algorithm for this particular time point. And that's all there is for level 1 curves. Our next video will focus on the next level of data, which is our level 1.0.1 curves. Those take into account these outliers that have been detected and removed. Thank you.